Hello everyone, this is Prasanna Kumar Kota and I'm here to give an update and a presentation on our project Avatar. So from the last time you've seen me, this is what we as a team have done, what our key learnings are and what the outcomes are. So we built a multi-step AI video generation pipeline, end-to-end integrated machine learning models. Models that we used were line of speech, DiffDub and RVM with a web application. We learned how to manage asynchronous video generation using background cues, and we handled media uploads and previews using GridFS. Now for the front end, we have Next.js. Our application has a rather large amount of components that do not require any client interaction. As such, we went with Next.js because not only is it easy with the routing, it's also the default, by default, all components are server-side rendered in Next.js. For the styling, we've used Tailwind CSS, and for the UI components, we used Chatcn. In the backend, we have Flask, where the models are running, and there's an API endpoint. And then we have BullMQ for the video processing queue, REST APIs as an integration layer as a buffer. The models, again, we used Smalley. This is the line of speech model for text to speech, DiffDub for the talking head synthesis, and Generation RVM for background editing, which is one of the features that we have introduced from the last time, that we didn't do the last time. We are using three databases: MongoDB, PostgreSQL, and Redis. MongoDB has all of the client data, all of the user data, any videos that the user generates, all of that is in MongoDB. PostgreSQL has predefined data, the default avatars and the default voices, among other things. And Redis has only the job data, that is the different jobs running, the text to speech and then the talking head synthesis. And we faced many challenges during during our development journey, but fortunately we were able to find solutions for it. So some of the challenges we faced were decoupled ML tasks. So we wanted to prevent UI lag. So we used that, we solved that by using BullMQ and Redis as in the background, as it has and create a queue. Then if the user lost progress, if the page was refreshed. So if I'm generating a video and I happen to go to a different web page, or I happen to go to a different place in that web application, I would lose progress and have to start all over again. So we fixed that by creating a local storage to track job IDs and status. Then if we had large video files that were generated, input output was very slow and the retrieval took too long. So we implemented MongoDB with GridFS in order to help smoothen this area. And then incomplete video generation on errors. So there were a couple of errors that we faced during our video generation. So to keep better track and to avoid further, we included failure checks and error logging. Now the reason why we chose Smalley and DiffDub, so we'd gone over multiple models before, and for the talking head synthesis we focused on sync quality, synchronization quality, speed and realism. For the TTS we focused on voice, speed and fine tuning. And while they may not have been the best of all, they were the most useful with respect to our application. They were the ones that would be the best just for our application. And these are some of the other models that we had looked at, and the reasons why we didn't take them, like speed was slow here, or there was no fine tuning option here, or there's no realism here, or there's it's very slow speed, or the synchronization quality was very robotic. And eventually we intend to deploy. And for the deployment in the front end, we intend to deploy the front end and back end separately. And the front end on Vercel, because it's free and optimized for Next.js, so we would not face any issues there. For the back end, we intend to deploy on modal.com, which provides up to an amount of GPU at the free tier. Because we're running inference for two models, we require GPU. Then for the model execution, we have a Docker image, so the requirements for the Python and all of the packages don't get lost, and it's just an easier transition. Let's take a look at our application. Now this is our landing page. We've taken our inspiration from many different professional places that provided similar services, and this is what we came up with. So we have our features, our pricing, and our testimonials, help obviously. We can get started here, and that would lead us to the sign up page. I have already created a dummy account so that I can showcase the utilization of this application. So we have actually implemented email verification. So this mail would get a email and they would have to click on that and verify. But for this case, I injected data into the database so that I can just move on with this as a test to test our application as a test user. There's also obviously Google and GitHub authentication. So they are both OAuth apps. And then this is our first page. This is the workspace where we run everything. We have my videos. So I've previously done 2. We have the trash. I haven't deleted anything. With the avatars, we have split it up into 2 different parts. So you can create an avatar, one that you want, so you can just create it here, or we have a couple public options that are always available and that are common for everyone. So for creation, it's very simple. You just add a name, PKK for this case, and then we are recording it live because we don't want any cases of mistaken identity or any false identification. Similarly, for the voices, you can also create a custom voice right here. We provide an anagram that you have to read and record yourself live, or you can just use one of these public voices. We have also implemented an edit background option, right? So we can just select a video, let's say for this, and then I can just click background and I can select anyone I want and I can just apply the background. There's custom backgrounds too, but for this particular test user, I have not given him the premium access. We also have the settings, obviously, so we can change all of our profile information. We have ample information, billing history too, and then for the security, we can change our passwords, request data export, which would execute a query that would remove all of the data of their data from us in order to ensure security. And then obviously we have some accessibility settings. We also have feedback. All of this would be mapped to the particular user that has sent the feedback. That way we would be able to provide personalized solutions. And then we have help and support, and we have FAQs, guides on different stuff, or like getting started, advanced voice settings, customizations, and then we have contact support. This currently will just send an email to one of the developers, that is us. Now let's see the application in action. Let's go to the workspace and then just say hello. For this case, why hello? Because it's small enough that it would not be a burden on any of the systems I'm running on, and it's easy enough to run. Now this data will go right here, and this worker that we are running, the Redis particularly, takes the job and sends it to our TTS model. Currently I'm running the TTS on that is line of speech on Lightning Hub. So this provides us a certain amount of GPU for free. So while development, we've opted for this. As you can see, we have the audio input token size and then the shape. This, once it is done, will generate an audio which is then sent back to the worker, and this worker then sends it to our diff. Now it's going to take a very long time for the recording to be finished. So instead, I'll show you some of the outputs that we have received. So back in my videos, here there's a couple of videos that I've generated. I can just play them. It should give me a nice preview here right away. I can move it, I can do full screen and then escape, and then I can just click that, and of course I can delete it, and just I have to click delete and then we move to trash and then come to trash, and we can see it right here. And we also have the restore capability on our trash, and after 30 days. So what we did is we used our sign in as a trigger, and as soon as a user signs in, we look at all of the videos that the user has generated, and we also have the timestamps, as you can see. This was when it was deleted and also when it was generated, right? So we compare that, and if it's more than 30 days, we delete it from our database. And obviously you also have the download option right here, so I can just get download, and as you can see, very easily it has already downloaded that, and I can access it in my own private system.
Hello, this is a test.
There we go. That's about the entirety of our application. That's how far we have come so far. Eventually we also intend to deploy this the front end, the back end, and the execution via a Docker image. So this is our future scope, what we intend to do over the next week, and we hope that you will be around to stick around to see that.